A-Level Mathematics. This is chapter 12.2. We're still dealing with vectors. These are vectors, equations of a line in 3 dimensions. Now the difference that we have here, idea of gradient of a line does not carry over into 3 dimensions. However, you can still use vector to describe a direction of a line. In 3 dimensions, lines which are not parallel may or may not meet. Non-parallel lines which do not meet are said to be skew. So for 12.2.1, points A and B have coordinates of this and this. Lines AB meet the XY plane at C. Find the coordinates of C. So first thing I'm going to do, I'm going to find the vector. So to find the vector, it's actually going to be B minus A gives me my vector. So it's going to be A, B right here. B minus A is going to be -2, 9, 1 minus A, which is -5, 3, 4. And that's going to give me my vector. So that's going to give me right there +3. Right here, that's going to give me 6. Here, this is going to give me -3. So I have to reduce this. Since they all have a common factor here, I'm going to reduce this. So let me see. If I reduce it, it's going to be by a factor of 3 times 1, 2, -1. So I took this out to show what I've reduced it by. So this is actually going to be my factor of that. So this is my vector. So let's turn it into the equation. So the equation is going to be right here. So it's A, B. So it's let me see. A, B. This one's A. This one's B. So I'm going to take my A. So R is equal to my A, which is going to be -5, 3, 4 plus T, quantity of my vector, which is 1, 2, -1. So now there's my equation of that. Now if I take a look at the XY plane, right there I have Z is equal to 0. So in my XY plane, Z is equal to 0. Think of it like this. If you're crossing the Y-axis, so if you're going to cross the Y-axis, X would be equal to 0. Okay, so XY plane, Z is equal to 0. So if this was the YZ plane, X would be equal to 0. So we're going to go through and we're going to use that a little bit more later. So now let's take a look at my equation right here. So now if this is my X, my Y, and my Z, so I have to set Z equal to 0. So when Z is equal to 0, we have to find my T for that one right there. Right here for this, I'm going to have, this is all my Z, so it's going to be 0 is going to equal to 4 plus -T, because it's T times -1, it's going to give me -T there. And because right here it's going to be X, Y, Z, when Z is 0, we're going to find out what that T is, and that's going to give me the whole thing. So let me see, move that over, that's going to be -4. I'm going to get T is +4. So now that T is +4, I actually have all my answers for this one right here. So now I can go through and plug it in and find the rest of it. So let's take a look. So for this, my X is equal to -5 plus T. My Y is equal to 3 plus 2T, and Z is equal to 4 minus T. There we go. So now if T is 4, this is going to give me X is -1. Here, if T is 4, that's going to give me 8. 8 and 3 is going to give me Y is 11. And Z, right here, 4 minus 4, 0. So this right here is going to be the point So this is my right here. So point C is going to be located at my -1, 11, 0, and or we can call this position vector. So right here, this next one, I could also say that it's going to be, I could rewrite it as -I, so that's going to be my -1 right here, plus 11j, and I have 0k, so I could write it like that. And my coordinate point, so coordinate is going to be at -1, 11, 0. (12.2.2) Find the value of u for which the lines r equals j minus k plus s quantity I plus 2j plus k, and r is equal to I plus 7j minus 4k plus t quantity I plus uk intersect. So I'm going to actually find when these two things are going to be equal to each other. So I'm going to rewrite it. I'm going to write it in the standard notation. And for this one, because the ijk doesn't work out very well for me, so I like writing it out. So this is going to give me x is equal to ijk. So let's rewrite it. So my I is going to be 0. So I'm going to have 0, okay, plus this one right here. Right here, this is going to give me s. Y is equal to, okay, y is my j value, so it's going to give me 1 plus 2s. Z is equal to -1, and right here that's going to be plus s. So there's that one there. And now let's take a look at my other one. My other one's going to be the x is 1 plus t. The y value is going to be 7 plus, now right here I don't have a j, so this is actually going to be just going to be my 7 here, because that's plus 0j. I'll write that down just to show, because I have no j there, and that's 0, it's not j, it's t. 0t, t is my variable there. So 0t, and my z value is going to be -4, and this one's going to be plus ut. So now I have all that written out. So I'm going to go through, I'm going to try and solve for this. I'm going to solve for this here. So I'm going to set these together. So let's rewrite it. So over here I'm going to have s is equal to 1 plus t. This right here is going to be 1 plus 2s is equal to 7, because that's 0t. 0t, that's actually going away there. And right here for z, it's going to be -1 plus s equals -4 plus ut. Now we're going to go through, and we could use this system of equation, but the easiest thing is going to be substitution. Because using substitution, if you notice right here in the second one, I only have s's, I don't have a t's. There is no t, so I'm going to take that one. Using substitution, I'm going to say, let's move that to the other side, so I'm going to say 2s is equal to, so if I subtract that, 6, I get s is equal to 3. So now I know what s is. So I don't actually have to do much more than this, but I can solve for t now. So if s is equal to 3, let's take a look. So if s is equal to 3, This is 3, this is 1, here's my t, so I'm plugging in right here. So subtract that, and it's going to be 2. So t is equal to 2. So now I'm going to find the points in which these things intersect. Let's take a look. So for this one right here, I'm going to go ahead and plug it in. And so for either one, it doesn't really matter. So let's say, for instance, I have my s, so I'm going to plug it in here. So this is going to be my x value. So the x value is going to be, so plugging in s, that's going to be 3. The y value is going to be, so 6, 7. And my, right here, my z, it's going to be 3, so it's going to give me 2. So I have 3, 7, 2 is going to be my coordinate. 3, 7, 2. Now I need to go through and try and find where is u going to be. So I'm going to plug in, because I know the value. I know the value right here for t, and I know the value for s. So I'm going to plug those in right there. So let's take a look. I'm going to say -1 plus 3 equals -4 plus, right here I'm going to have t is going to be 2, so that's going to be 2u, because I'm trying to solve for u here. Combine those, I'm going to have 2 equals -4 plus 2u. Move this the other side, so it's adding it, so 6 equals 2u, and so I get u is equal to 3. So I've gone through, I found everything. I found right here the value of u, and I found the point in which that these intersect. So this is going to be the coordinate where they intersect at. Determine whether the points with coordinates 5, 1, -6 and -7, 5, 9 lie on the line joining A to B. So first thing I need to do, I need to make an equation out of it. So give me the equation, and to start with my vector, which is going to be the b minus a. So the b minus a, so it's going to be with these points right here, lie on the joining right here. So we're checking these two, and these two right here are on my line. So this is my line AB. So it's going to be line AB. So right here, I'm going to start with my -3, 3, 4 minus my 1, 2, -1. Do my subtraction right here, and I should come up with, let's see, -4. This is going to give me 1, and this is going to give me 5 right here. So this is going to be my vector right here. This is my direction that I'm going. And so it's AB, so I'm going to pick out A. So R is equal to, let's see, we have my A, which is 1, 2, -1. That's a 1 right there. And that's going to be plus T quantity of my vector minus 4, 1, 5 right here. So now I have my equation there. So what I'm going to try and do is I'm going to check to see if these things are going to be possible for this to be correct. So for this to be correct, all I have to do is set my x, y, and z equal to my x, y, and z over here. And then I solve for t. If every t is the same, that means that it is going to be true. So it's going to be a yes. So let's try that first point, which is here. So I'm going to have 5, 1, -6, and that's going to be equal to, so let's see right here, equal to, it's going to give me 1 minus 4t. This next one's going to be, the 1 is going to be equal to 2 plus t. And my last one, my -6, is equal to -1 plus 5t. Let's solve for t. Let me see, subtract 1 from both sides. I should get t is equal to -1. Subtract that one right there, and I should get -1. t is equal to negative 1. I'm going to add it right there, so I should get a negative 5. Divide by that, so I should get t is equal to negative 1. So they're all the same. So this point right here does lie on this equation. So it is on there. Now let's try the other one. So my other one is going to be negative 7, 5, 9. So negative 7 is equal to 1 minus 4t. 5 is equal to 2 plus t. And 9 is equal to negative 1 plus 5t. Let's see what we get here. So for right here, I'm going to subtract, so that's going to make that a negative 8. So here I get t is equal to 2. I'm going to subtract, so I get 3. T is equal to 3. And right here, let's go ahead add, so it's 10, so t is equal to 2. Because of that one right there, this is a no, because of this piece. If they're all t equals 2, then that would be a yes, it is on that line, but because of that one right there, this one's going to be a no. Alright, 12.2.4, prove that the straight line with the equation r equals, all this right here, meets the line joining this point to this point, and find the cosine of the angle between the lines. So we're going to find the cosine of the angle between lines. We're not finding cosine, we're not trying to find the angle, we're trying to find the cosine of the angle. So we want to figure out what cosine is equal to. That's what that means. Alright, so let's take a look. So first thing I'm going to do is I'm going to make an equation out of these 2 points right here. So I'm going to get my b minus a, and it's going to give me my vector. And that's going to give me 3, 3, 5 minus 2, 4, 4, 1, negative 1, and 1. So I have this my vector right here. So now my equation is going to be r equals 2, 4, 4 plus, I'm already using t, so I'm going to use an s here, and this one's going to be 1, negative 1, 1. So now I have this equation and this equation, so I want to see where they meet. So I have to figure out where they meet at now. So we're going to do the intersection of this line and this line, so I'm going to set these equal to each other. So I'm going to I'm going to rewrite the whole thing first. X equals 1 plus 2t. Y equals 2 minus t. Z is equal to negative 3 plus 4t. On the other one, it's going to be x is equal to 2 plus s. Y is equal to 4 minus s. And z is equal to 4 plus s. There we go, set them equal to each other. So I'm going to get 1 plus 2t equals 2 plus s. Next one's going to be 2 minus t equals 4 minus s. Right here I get negative 3 plus 4t equals 4 plus s. Now I'm going to rewrite this one more time, but I'm going to move all my variables to one side and my constants to the other. So I'm going to try and turn this into what looks like a system of equation. So I don't have anything that pops out automatically that's going to tell me I'm going to want to use substitution. So I'm going to actually have to use some elimination on this one then. So let's do some elimination. So right here I'm going to have, let's see, that's going to be a negative s plus 2t equals, move that over there, 1. Over here I get s minus t equals, subtract that, positive 2. Over here I should get a negative s plus 4t equals, that's going to give me 7. Now, the next thing I'm going to do, I'm going to look for a way to eliminate one of these right here. So it looks like I'm going to use these for my elimination. So when I add those two together, my s's go away, and I should be left with, let me see, that's going to give me t equals 3. So now I get t is equal to 3 because I used elimination on those two right there. Now I could plug t back in and I'm going to find s. So if I plug in t, I'm going to use this one because this one looks a whole lot easier. So right here, so if this is 3, I'm going to add 3. So s is going to be equal to 5. So I got t is 3, s is 5. So let's go ahead and plug that in. I could pick either equation because they're both going to be the same point. So let's go ahead and let's plug it into my first one. So I'm going to plug it in right here. So it's going to be x equals 1 plus 2, my t is 3. Y is equal to 2 minus 3, and z is equal to negative 3 plus 4 times 3. So right here I get x, so my coordinate is going to be, 6, 7. Right here I'm going to get negative 1. Right here I get 12 minus 3 is going to be 9. So my intersection is going to be right here. So I got my intersection now. So that's important. So now the next thing I have to do, I have to find the cosine of the angle between those. Now what we're going to do is we're going to actually have a little bit of notes, and this is like halfway through. I know we're not done with the problem, but I need to explain something first. Alright, the angle between the lines is called the angle between their directional vectors, calling this angle theta and using scalar product or dot product. So first thing right here, okay, scalar product, dot product, it actually refers to the same thing. Now we have magnitude of P times the magnitude of Q times cosine theta is equal to LU plus MV plus NW. So what those are, it's going to look like this right here. I have L, M, N times U, V, W right here. So this is actually going to give me this portion right here. And magnitude, so magnitude of P, so magnitude, so let's take a look. So for magnitude, it's going to be the magnitude of P is equal to the square root of my directional vector for P. So now P is actually just going to be my first vector, and Q is going to be my second vector. So my first vector, if I go back right here, my first vector was 2, negative 1, 4. So I have 2 squared plus negative 1 squared plus 4 squared. And my direction, or my magnitude for Q is equal to directional vector of right here. Let's see, for this one right here, so it's 1, negative 1, 1. So 1 squared plus negative 1 squared plus 1. So that's going to take care of that, and I still have to do this with my for this part right here. So this is going to give me, let's write this out. So LMN is going to be my first one, which is right here, 2, negative 1, 4. That's going to be times my other one, which we said is going to be 1, negative 1, 1. And so let's go ahead and multiply these out. So it's going to be, so LU, it's going to be in this order right here. So this one's going to be, let me see, 2 plus 1 plus 4. So that's what I'm going to get from here, and now I have to start plugging in that too. So that's going to be this part of this equation over here. Now I have to plug in the magnitude of P. 2 squared is 4 plus 1, so this is going to be 4 plus 1 plus 16. So it's going to be, let's see, square root of 21 times 1 plus 1 plus 1, so that's going to be 3. Square root of 3 cosine theta is equal to, now all this part right here, we just did this over here. So all this piece right here goes together. All that goes together. So from all this right here, I got 2 plus 1 plus 4, so that's going to give me 7. Now we're trying to find cosine theta. We're actually not trying to find the angle itself. We're just trying to find cosine theta. So let's take a look, multiply those together. They both have a 3, so it's going to be 3 square root of 7 cosine theta is equal to 7. Divide both sides by 3 square root of 7. So cosine theta is equal to, right here, 7 over 3 root 7. So rationalize, square root of 7, square root of 7. So right here, I'm going to come up with, let me see, that's going to give me 7 down here, and I already have a 7 on top. So cosine theta is going to end up leaving me with square root of 7 over 3. Now that's giving me cosine theta. Now if I was looking for the angle here, now I have to try and get it by itself. So it would be theta is equal to cosine inverse of square root of 7 divided by 3. So let me grab my calculator. So right there, I have, make sure that it's in degrees, because that's what usually we're looking for when we're doing it like this. So we're looking for the angle in degrees, and so for this one it's going to be second cosine square root of 7, close it, make sure that's closed because it's only square root of 7, because if you go divided by 3 it keeps it inside the radical. So right there, divided by 3, close. So that's really important. And let's see what we get. Come out with my angle is 28.1. So theta would be about 28.1 degrees. But right now I'm not looking for that, but later on you will see it is going to ask for that. But right now for this one, it's only asking for this. So yes, this problem had a whole bunch of mess to go along with it. So this one right here, I'm introducing dot product. So it's magnitude of this. So it's a square root of right here, and same thing for this. So that's going to be magnitude times cosine of all that. So hopefully everything comes out all right. If you have any questions, please don't be afraid to ask. I have the practice right here, page 168, 1 through 7, 9, and 13. Homework: 1BC, 2AC, 3, 4AC, 5A, 6B, 7A, and 9.